Okay, we're gonna start because I don't care. They're not here. It's their problem. Okay, so we did molarity in chapter 5, and that is one way that we define how much solute is in a particular amount of solution. But there are a lot of different ways to define that, to define concentration, and we have to be familiar with a lot of them because we'll use them in different calculations, just kind of depending on which one makes more sense. So we talked a lot about concepts and like qualitative ways to define concentration before, and now today is all about quantitative stuff. So kind of a couple caveats. We will not have time to get through all of the examples that I put in the slides, but I did that on purpose so that we have extras that you guys can practice over the weekend. So I'm recording this and I'll post this video. So if you're stressed, like you can't keep up with the notes, if you're not following along, focus more on trying to make sense of what's going on and less on like copying everything down, because you can always go back to the video and refer to that. And then later today, I'll make a second video that has all of the ones that we didn't get to, so you can use those as practice problems over the weekend. Because like so many of the math things, the best help in this case is practicing them. Like concepts, you can review the concept and you can answer conceptual questions from the homework and stuff, but the only way you get math stuff is not by looking at the equations more, it's by practicing it a bunch, okay? So finish up the problems that we don't get to in class, check your answers with the second video that I'll post today, and then start in on the homework. So Monday's class is relatively easy. That's the end of chapter 14. So there's not a ton on there. So you have almost all of chapter 14, and this stuff in particular I think would be a good focus for your study over the weekend, just because it's probably the more time consuming, okay? But just gauge it based on how comfortable you are. If you're feeling pretty comfortable with these, do the extra problems from the notes, and then you should be pretty good to go, okay? All right, so the first question is gonna start with molarity, which we've done before. I'm also going to introduce molality so that when you finish the molarity one, you can jump forward. And if you don't quite get to it, that's okay. We'll do it together. Okay? So all of these units have a defined, kind of more detailed unit breakdown, let's say. Like we know that molarity actually means moles of the solute over the liters of the solution. Now, in the past, we just always said moles per liter. We need to be really careful today about specifying, is it the solute, is it the solvent, or is it the solution, which is the two together? Because we're gonna use all three of those frequently, and it's very easy to get them mixed up. So I'm gonna specify moles of what, liters of what every single time. Now, all of these definitions are in this table. They're also, they're written slightly differently, but they're also in the exam equation sheet. So I would say rather than looking at the table while you're doing the practice problems, when you're at home, as well as when you're doing the homework, is use the exam equation sheet, because then you know how much you need to know for the exam, and you're going to be more familiar with like where it is and how it's worded and stuff, okay? Okay, so molarity, that's the one up here. We just defined it, and we've done that one before, so that shouldn't be hard. The second one we're going to look at is molality. So very close name, and it's a small m instead of a big M, okay? And its defined units are moles of solute again, over kilograms of solvent, okay? This one's particularly useful because it's not temperature dependent. Volume of solution, because density changes with temperature, that's actually the molarity will actually change slightly with temperature changes. So it's not useful in a lot of instances because of that, okay? So molality, which is going to be the second part of this question, moles of solute per not kilogram solution, but kilogram solvent. And in this case, we're talking about sucrose is our solute and water is our solvent. Okay, so I'll set a timer so I don't cut you off too soon, 3 or 4 minutes, and let you guys solve these two. And I'll start working them, halfway into that.
Looks like a couple came.
Yes, at least we got a couple more people came in. I realize it's a dreary day, but that's not a reason not to come to class. Oh, no. I think I must have typed that in slightly wrong. It's 0.414 molar. Okay, so first one's up there if you want to check your work. Remember, when you have things like this where you're trying to solve something that's a unit over another unit, you find one, you find the other, and then you divide one by the other. The second part should be relatively straightforward because you've already found the moles of solutes. You got to just plug that in again. If you get like a slightly different number, like I just redid it without rounding and got 0.415 for the molarity, don't stress. Like I said, it's just if you round at a different spot, it's not like you're gonna be off enough that you're gonna question your answer. But
To clarify, the 342.296 is the grams per mole of sucrose.
of sucrose, yep,
Yeah.
yep. Okay, and then for the molality, like I said, you already solved the moles, so you just reuse that number, and then the kilograms of solvent, the water, is already in the question. So that one's literally just one over the other. Okay, so this one should feel relatively straightforward, just kind of reminding you, yes, molality is new, but it's like relatively clear definition, just kind of plug the numbers in. So we'll do another 2 of these that are using new concentration definitions, same data, like we're gonna keep using the 50.4 grams of sucrose so you can reuse the mole values. And then we'll do one that's a little bit harder because it's going to take us starting with a concentration unit, going to a different concentration unit. Those are probably the hardest type. So we'll do a couple of those as well. Okay. All right. So the next 2, like I said, same data, but they're using new concentration units. So this is like a new definition of how we're defining solute amounts. So the first one is mole fraction. This is usually abbreviated by like a curvy X. And specifically, it'll put at the subscript, it'll say what it's the mole fraction of. In this case, we're doing sucrose. So I won't use that abbreviation. Usually I'll just say, tell me the mole fraction of sucrose. But if you see that, and I think I use that symbol on the exam equation sheet, like I have the curvy X and then I have it defined. So mole fraction is just like it sounds. It's a fraction, which we're going to use fractions. We're also going to use percents, which is just fraction times 100. We're also going to use parts per million and parts per billion, which is a fraction times a million. or a fraction times a billion. We use it for really small quantities. Okay, so the moles is, and this is true of all of these types, moles, percents, fractions, all of those, is the moles of solute over the total moles in the solution. But to be even more specific, because sometimes you will need to do this, the moles of solution is actually the moles of the solute plus the moles of the solvent. Okay, so moles solute on top, and then the moles solute plus the moles of solvent on the bottom. Okay, so same data. You can go ahead and do that one, but we're going to first talk about mass percent too, so you can do them both at the same time. Okay, so mass percent, now we're not talking moles over moles, we're talking grams over grams, and it's also a percentage. So very similar to the one above, this is now going to be grams of solute over grams of the whole thing, the solution. Or you can rewrite that, because you're going to need to in some instances, grams of solute over grams of solute plus grams of solvent. Okay? Because this is a percent, if I just left it like this, it would be a mass fraction. Because it's a percent, I multiply by 100. So cent means 100, like century. Okay, so go ahead and work on those two. I'll give you a few minutes to do that. Okay, so I'll go ahead and start solving that out. And feel free to use the stuff that you have from before. So the 0.147 moles of the sucrose. But now I'm also going to have to convert this 0.332 kilograms of water into moles of water, because that's my solvent there. Okay, so kilograms to grams, and then using the molar mass of water. So 18.43 moles of water. This shouldn't be surprising, like it is going to be a lot more because it's the solvent, so that should make sense. So 0.147 moles of sucrose on top, on bottom 0.147 moles of the sucrose plus the 18.43 moles of the water. Okay, I'm just going to double check that because it seemed a little bit, I didn't remember that from my last class. So let me just make sure. No, that looks right. Okay. All right, so the mole fraction here, 0.00791. Now, we don't usually write units with this because it's moles over moles. We kind of think of them as canceling out. Usually it would just be expressed as mole fraction equals 0.00791. If you wanted to write a unit, you would write mole sucrose over mole solution. And then for the mass percent, we just need to make sure those kilograms of water are in grams, and then it's pretty straightforward. 50.4 over 50.4 plus 332 for the water. And then we're timesing this by 100 because it's a percentage. And I get 13.2%. Okay, so general, these last 2 pages, general direction is start by defining the unit as specific as you can. Then find each component and plug those in, whether it's moles or grams or whatever. Okay, any clarifications, questions? Okay, yep.
I was gonna say, for some reason, I initially interpreted mole solution as its own thing, but in reality, mole solution was solvent plus
Yeah.
solute.
Yeah, because you don't know that. You don't know the total of the mole solution. Like before, when we had liter solution, like we knew that value. But for mole solution, you very often have to break it down into solute plus solvent. Yep. Okay. All right, so the next one's a little bit more complicated because now what we're doing is we're starting with a concentration unit, so 10.5% glucose, and we want to then convert it to a different concentration unit, molarity and molality, so 2 different problems there. Okay, so the reason why this gets more complicated is because you're not given like the little bits of information you need, you're given a starting concentration, which is lots of different components. Okay, so try to follow along with this because it can get a bit confusing at this point. So if it's 10.5% by mass, we're going to do the same thing as if we were just told mass percent, and we're going to break it down into its components. But now we have numbers associated with those components, okay? So mass percent is normally grams solute over grams solution. That's just like the unit definition. But now we have an actual, percent would be times 100. But now we have an actual defined number, 10.5, okay? So when you do percent, per means divide, 100, cent. So if you're finding the mass percent, you multiply by 100. If you're given the mass percent, that value of grams is per 100 grams of the solution. So when it says 10.5%, it's 10.5 per 100. If it was 10.5 parts per million, it would be 10.5 divided by 1,000,000 grams. So just keep in mind, it's different. If you're trying to find mass percent, that's when you multiply by 100. If you're given the mass percent, that's when it's per 100 grams. Okay, and then we're converting to molarity. So I'm going to rewrite that, like redefine that in its units. So that's moles of solute over liters solution. Okay, so the top shouldn't be too hard. That's just a gram to mole conversion. The bottom, though, is where we're going to need to use the density, because that's what helps us convert from grams to a volume. Okay, so let's just do this one at a time. We'll do the molality separately. So go ahead and take 2 or 3 minutes to do this conversion and determine the molarity, knowing this much information. Okay, so work up on the board, find one, find the other, then divide. So again, the thing that's different about this is we're starting with a concentration unit. So like that information that we're looking for is already embedded in a concentration unit. So we kind of have to like break it out first in order to get the little components, then we can convert them to the new thing. Okay, so 0.6 molar is what you should come up with there. And then I'll keep this showing. I'll just start to summarize the next one on the next slide, even though it's, just cross this out for a second so that you don't get confused. Okay, so the next one is molality. So we're starting with the same thing, so I'm just gonna copy that. Okay, starting with the same thing, but now we're converting it to, I'm gonna leave a little space because we're gonna need something else here. We're converting it to molality, which is still moles of solute on top, so that's nice. We already found that, per kilograms solvent. Okay, so we've got an issue here because the starting thing has grams solute and grams solution. It doesn't tell us anything about the solvent yet. So there can be some, difficulty, like how do I get information about the solvent there? What you have to remember is that grams of solution on the bottom is actually, I'm going to say this is equal to grams of solute plus grams of solvent. Okay? So 10.5 grams of solute, right, on top. So if we know that the bottom has to equal 100, and we know that there's 10.5 grams of solute, we can figure out then that there's 89.5 grams of solvent, right? So you're always going to have this number is going to be on the top, and then it's part of the bottom. So I'm going to rewrite that 10.5 on the bottom, and then I'm just subtracting it from 100 to figure out how much solvent there is. So 89.5 grams of solvent. So I didn't have to do that in the first problem. I didn't have to break it down because it was solution, right? Solute, that's easy. Solution, good. Here, solute, so that one was pretty easy. But because I had solution and I'm changing to solvent, that's kind of my hint that I need to go more detailed on the bottom. I need to break that 100 grams down to how much of that is solute and how much of it is solvent. Okay, so finish up that part of the calculation. Shouldn't be too bad because you've already solved the moles of solute and you're really just converting grams to kilograms for the solvent. And feel free to ask if you're like, wait, where did you get such and such number? Because I realize there's, these are the hardest types of these problems. When you're starting with a concentration unit, go into another concentration unit. So I put the numbers in there. The moles is coming from the previous question. And the kilograms is just the 89.5 converted from grams to kilograms. So that one comes out to be 0.6. I'm just double checking because usually molarity and that is 0.6. Okay. 0.651. And then we write it with a little m. I think I said this before, but a little m, and it's called molal. So 0.651 molal, whereas the other one's 0.6 molar. Just make this smaller so you can see all of it if you need to. So these are definitely going to take some practice. Okay, so the last one that we'll probably have time for is this one here. We'll see. This is how far I got with my other class, so. Okay, so this question says, what mass of sucrose? Okay, so before we even move on, it's not asking us to calculate a concentration unit. It just wants grams of something. What mass of sucrose is contained in a particular volume if it has 11.5% sucrose? Okay, so it's giving us a concentration unit and then asking us just for individual data. It's not asking us for a new concentration unit. So let's just like highlight the key things so that you can kind of see how would you know how to approach this. So mass, volume, a concentration unit, and a density. Okay? This is telling you, because it's only involving one concentration unit, you're starting with one, you're not converting to another, you're actually using the concentration unit now as a conversion factor. So we did this a ton with molarity in chapter 5. You know, you're given a particular volume and you have to calculate the grams in a solution with a particular molarity. But we've never done this with mass percent. So let me just set up the calculation for us. So I'm going to do this down here. So remember when we do these, we start with whatever is the number with one unit. So 355 mils. That's the only place we can start, or that we should start if we have that. Let's say it that way, because other ones, obviously, we've not done that. If we can start with a thing that just has one unit, let's start there. So we're going to start with that number, and we're looking for grams sucrose. So we're going to have to do like our regular dimensional analysis to get from milliliters to grams of sucrose. And to be really clear, milliliters of solution to grams of sucrose. So we must be using the density and the concentration unit to get us there. Those are going to be our conversion factors. And just to, remind us, 11.5% means 11.5 grams of sucrose per 100 grams of solution. So now that we've written it that way, now it is pretty easy to use as a conversion factor because it's one unit above another. We can flip it as needed. So go ahead and use that and use the density and get yourself from the 355 to the grams of sucrose. This is really gross too, because this is like basically a 12-ounce can of soda. You'll be really kind of grossed out when you see how many grams of sucrose is in there. I am very like anti-sugar. We don't not drink. I know aspartame is bad for you and all that. Whatever. I swear sugar's way worse.
Is it just me, or do you like sugar less when you get older?
Well, you still like it. You just see how bad it is. Like, you know, yeah.
I noticed that with myself, so.
Oh, already? Okay, there you go.
A
Yeah.
little bit.
Well, kids are always like candy crazy.
Yeah.
But no, I still really like have a sweet tooth. I just know, like, you know, your metabolism slows down and you're like more responsive to blood sugar drops and stuff like that. Okay, so I'll start working this since we're getting a little low on time. Okay, so 42.5 grams. I think I've heard somewhere you're not supposed to have more than like 20 grams of added sugar in a day. Not to freak anybody out. So like, it's like 2 days of sugar in one soda. Okay, so I'll post I'll post this and then I'll post a second video with the rest of the problems. And that would be your first step, is just try to get through the other practice problems to feel more comfortable with this. And then ideally do the homework over the weekend too. Okay?
Oh, by the way, where'd you get the 1.04 gram solution?
The density, 1.04 grams per mil.
Yeah, somehow I missed that.
Yeah. Almost always, if you're doing a volume to mass change, they're got to give you the density for that.
Yeah.